So today we're going to be working on deriving the formula for the area of a circle. So we're first going to talk over some stuff that we've learned in previous classes. So do you remember what the circumference of a circle is?
It's 2 pi r.
And what does the r represent in that?
The radius.
Represents the radius. And how do we define the radius?
The radius isn't like across the circle?
Almost.
There.
The radius goes from the center of the circle to any point along the circumference of the circle.
Yeah.
So what does the circumference of the circle represent?
The outside of the circle.
It represents all the way around.
Yes.
The length all the way around. So today we're going to be working on our ti-Nspire calculator program. And it says, in this activity you will develop a rule for finding the area of the circle. The circumference of a circle is the pi times the diameter, or 2 pi times the radius. And the area is the covering of the shape, so it's the whole shape. We also talked about some other area formulas before this. We talked about like for a rectangle and for a parallelogram. Do you remember the area formula for a parallelogram?
Base times height.
Base times height, yeah. That'll come into play today. So here we have your objectives. It says the students will give an informal derivation of the relationship between the circumference and the area of a circle. So go ahead, here's your circle. You can see that it's split into 4 sectors, and we're going to go ahead and read the first question on your worksheet. It says, if you were to move the pie-shaped sections of the circle to form another 2-dimensional shape where we could find the area more easily, what might the shape look like? Draw a sketch to show this new shape. So at this point they would work independently. They draw a shape of what they think that we could arrange these 4 sectors of the circle into to make it easier for us to find the area of the circle. Okay? He drew a rectangle. Okay, so on our program it says select any open point on the section of the circle and drag it below to the circle to form another shape. So go ahead and drag those white dots there. You have to touch the point. There you go. So in this situation, we would most likely be provided with a smartboard, and the students would take turns going up and manipulating the smartboard in front of the class. There you go.
Okay.
So it says, after you move all 4 sections, what does the new shape appear to look like? Does it look similar to the shape you suggested in question 1? So what does this shape appear to look like?
A parallelogram.
Okay, yeah, so that's pretty close to a rectangle, but not quite, because a rectangle can't be formed with the sectors of a circle. So it says, where does the circumference of the circle show up in the new shape? Draw a sketch below and show where the circumference appears in the new shape. So let's talk about what we know that the area of the parallelogram is base times height. So let's talk about what the height is represented in this parallelogram. So we know the height is going to be from this point all the way up to the top. So the biggest section.
The radius?
It's going to be the radius, because you can see right here, we go from the center of the center of the circle all the way out to the circumference. So that's going to be the radius. And then what's the bottom going to be? Think about the circumference of a circle. So you can see you have 2 halves of the circle up on here and 2 halves of them down here. So if we know the circumference of a circle is 2 pi r, what's half of that? Pi r, yeah. So we know that the height is going to be r. You can go ahead and write this on your page. The height is going to be r, and then the base is going to be pi r.
Okay.
I'm going to turn next to your page. And it says use this shape as a reference and its area rule. What might be the area formula for a circle? Explain your thinking. So go ahead and work independently on this. Take a look at your parallelogram and see how it would relate to the area of a circle. Remember the area formula for a parallelogram.
Base times height.
Base times height. Yep.
For a circle.
Think about it just in terms of the parallelogram. Look at the parallelogram you drew. You have your base is pi r and your height is r. So the area of that is going to be base times height. You got to multiply r times pi r, right?
Yeah. So you get pi r squared.
Pi r squared. Okay, we're going to move on. It says perhaps only having 4 sections in the circle didn't allow you to make a very convincing shape. Let's try using 8 sections and see what happens. Move the 8 sections in this circle by grabbing and dragging to form a shape. So we're going to move to this next page. And as you can see in this circle, instead of being in 4 sections, it's in 8. So we've doubled the amount of sections. So go ahead and manipulate the shape and pull those down into the new parallelogram. Make sure you pull them all the way into their spots. There you go. Okay, so what does this shape look like? How does it differ from what was created using the 4 pieces? So we'll discuss that. What shape does this appear to look like?
It's a parallelogram, but it's closer to like a perfect rectangle than.
Yeah, it's closer to a perfect parallelogram, right? Yeah. It looks more clean. It's not as curved as the first one, right? And it says, using this shape as a reference, what might be the area formula for a circle? So again, they're labeled right here. So it says r times pi r.
Pi
so
r squared.
Pi r squared, yeah. And it's a little easier to see in this situation. It says, how is a circumference connected to the area rule? So can you explain to me how the circumference is related to this problem? We talked about it when we were talking about the 4 sections. So how does it relate when we're talking about 8?
Well, I guess in the bottom and the top of the parallelogram, you include in that. Did you say how we include the circumference? Mm-hmm. Well, you still have, even though it's split up into 8 different pieces now, the circumference is still accounted for. Mm-hmm. Because it's on the top and also on the bottom.
Right. On the top you can see 4 of the 8 sections, so half of the circumference, and on the bottom you can see the other half.
Yeah.
So we know circumference is going to still be 2 pi r.
Yeah.
No matter how many sections it's split up into.
Yeah.
So the top is going to be pi r and the bottom is going to be pi r. Mm-hmm. It says, imagine cutting each of those 8 pieces of the circle in half so that there are 16 pie-shaped pieces. If you rearrange those pieces in a similar way as you did above, what shape would you make? How might it differ from the previous ones? So if you had twice as many shapes in that picture as you do right now, how would it be different?
It would be even closer to a perfect parallelogram.
Yeah. It'd be easier to see, and no matter how many sections it's split up into, it's still going to be a parallelogram, and it's still going to show us our area.
Yeah.
It says, how does putting more congruent pie-shaped pieces in the circle change the overall appearance of the shape you make with the rearranged pieces?
It just makes a more rectangular shape. The angles get smaller and the angles get like closer to 90 degrees.
you can't see like the curve of the circle as much.
Yeah.
Like imagine if we had this cut up into like 100 sectors. Yeah. It would be difficult to see that it was at one time a circle. It'd be hard to see that it wasn't a parallelogram.
Yeah.
It says, does the area rule you made for the circle change if you put more and more pieces in the circle?
No, because you're still, no matter how many pieces you put in it, you're still accounting for all the circumference.
Right.
Right.
The base is always going to be the same because it's always taking half the circle. No matter how many pieces you had, it's calculating half the circumference of the circle.
Yeah.
It says, how can you use this activity to explain the area formula for a circle? So go ahead and write about like 3 or 4 sentences just explaining how you derived this equation, this formula for a circle.
The equation pi r squared.
Mm-hmm.
Okay.
And at this point, the students, they'd all write just a couple sentences, probably a paragraph. This would be a good example of a writing activity that we can incorporate into a math classroom. There's not a lot of opportunities we have to do that, so this is a good opportunity for them to show their writing skills through math and be able to use correct and concise language in describing the derivation of a circle through use of the area of a parallelogram. And when they complete this, a couple students would volunteer, and we probably share with the class, and we discuss what ways they can word it better, where they had some holes that they need to fix, and we could display really good explanations. We could use that to form our definition for the area of a circle. Okay, would you like to share with the class what you wrote?
So basically, it's kind of just like your like the radius is giving you your height for your equation.
Sorry, I'm still listening.
Your radius gives you your height, and then your circumference is giving you the length of your equation. So it's basically about taking the radius and the circumference and turning that into base times height.
Mm-hmm.
And that's how you're able to solve for it.
Yeah. Okay. So does the size of the circle matter when we're calculating this area? Let's say I have like a really tiny circle versus a really big circle. Am I going to use a different formula for that?
No, you shouldn't.
No.
You shouldn't.
So we've decided that it doesn't matter how many sectors we split it into, and it doesn't matter the size of the circle. It's always we're always going to use the same formula no matter how we split those up.
Mm-hmm.
And at this point, they take these worksheets that they've filled out and they've worked on. They would submit those for a formative assessment, and then they would most likely take like an exit slip that would give them a couple examples of a circle, a couple examples of a parallelogram, explaining this a little bit more, and then applying that formula to a new circle where they're given the radius. They have to find the circumference first, and then they use that information to find the area.